For decades, the choice between a petrol or a diesel car has been a fundamental decision for motorists across the United Kingdom and beyond. These two types of internal combustion engines have powered our vehicles for over a century, each offering a distinct set of advantages and disadvantages that cater to different driving needs. Petrol cars have long been praised for their smoothness and responsive performance, making them a popular choice for city driving and shorter journeys. They tend to be quieter and often have a lower initial purchase price, which has cemented their place as the default option for many families and individual drivers who value comfort and agility on the road. On the other side of the forecourt stands the diesel engine, a workhorse celebrated for its remarkable fuel efficiency and impressive pulling power, known as torque. Historically, diesel cars were seen as slightly agricultural. They were noisier, slower to accelerate, and produced more noticeable vibrations than their petrol counterparts. However, modern engineering has transformed the diesel engine dramatically. Today's diesels are refined, quiet, and powerful, making them an excellent choice for drivers who cover long distances on motorways, where their superior miles per gallon can lead to significant cost savings over time. Their robust nature and high torque also make them ideal for towing caravans or trailers. The fundamental difference between these two engine types lies in how they ignite their fuel to create the power that turns the wheels. Both are classified as internal combustion engines, meaning the fuel combustion process happens inside the engine itself, within enclosed spaces called cylinders. This explosive force pushes components, which in turn creates rotational motion to drive the car forward. Think of it like a series of controlled, rapid explosions. The method used to trigger these explosions is precisely what separates the petrol engine from the diesel engine, leading to all the subsequent differences in performance, efficiency, and mechanical design that drivers experience. Understanding this core distinction is the key to appreciating why one engine might be better suited to your lifestyle than another. A petrol engine uses a spark to ignite a pre-mixed concoction of air and fuel, a process that is quick and allows for high engine speeds. A diesel engine, in contrast, uses immense pressure. It squeezes air so tightly that it becomes incredibly hot enough to spontaneously ignite the diesel fuel as soon as it is sprayed into the cylinder. This reliance on compression rather than a spark defines the character of the diesel engine and is the source of both its strengths and its weaknesses. The petrol engine operates on a beautifully simple and effective four-stroke cycle: intake, compression, combustion, and exhaust. This cycle is the heartbeat of the car, repeating thousands of times per minute. The process begins with the intake stroke. A piston inside a cylinder moves downwards, creating a vacuum. This suction pulls a fine mist of petrol and air from a component called a carburetor in older cars, or a fuel injector system in modern cars, into the cylinder through an open valve. The precise mixture of air and fuel is crucial for efficient and clean combustion, ensuring the engine runs smoothly and produces optimal power. Next comes the compression stroke. With the intake valve now closed, the piston reverses its direction and travels back up the cylinder. This movement squeezes the air-fuel mixture into a much smaller space at the top of the cylinder. Compressing the mixture makes the subsequent explosion much more powerful and energetic. Think of it like squeezing a spring. The more you compress it, the more forcefully it will expand when released. This stage prepares the mixture for ignition, concentrating its potential energy for the power-producing part of the cycle, which is about to happen in a fraction of a second. The third stroke is the combustion stroke, often called the power stroke, and it is where all the magic happens. At the very peak of the piston's travel, when the air-fuel mixture is at its most compressed, a small but vital component called the spark plug comes into play. The spark plug receives a high-voltage electrical charge and generates a tiny, intense spark inside the cylinder. This spark instantly ignites the compressed vapor, causing a powerful explosion. The rapidly expanding gases from this explosion force the piston back down the cylinder with tremendous energy, turning the crankshaft and delivering power to the car's wheels. Finally, the cycle concludes with the exhaust stroke. After the piston has been pushed to the bottom of the cylinder, the exhaust valve opens. The piston then moves back up the cylinder one last time, pushing the burnt gases and waste products from the combustion process out of the cylinder and into the car's exhaust system. From there, these gases are treated by the catalytic converter to reduce their harmfulness before being released into the atmosphere. Once the cylinder is clear, the exhaust valve closes, the intake valve opens, and the entire four-stroke cycle begins all over again, ready to produce another burst of power. The diesel engine also uses a four-stroke cycle, but with a crucial variation in the first two steps that defines its unique character. The process starts with the intake stroke, just as in a petrol engine. However, instead of drawing in a mixture of fuel and air, the diesel engine's piston moves down and pulls only air into the cylinder. There is no fuel involved at this stage whatsoever. This is a fundamental point of difference. The diesel engine is designed to work with pure, unadulterated air during the initial phases of its operation, which has significant implications for how it generates power and achieves its famed efficiency. The second stage is the compression stroke, and this is where the diesel engine truly sets itself apart. The piston moves up the cylinder, but it compresses the trapped air to a much higher pressure than in a petrol engine. A typical petrol engine might have a compression ratio of around 10:1, but a diesel engine's ratio can be as high as 20:1 or more. This extreme squeezing action causes the temperature of the air inside the cylinder to rise dramatically, reaching temperatures of over 540 degrees Celsius or 1,000 degrees Fahrenheit. The air becomes superheated, essentially turning the cylinder into a high-pressure furnace, primed and ready for ignition. With the air heated to its ignition point, the combustion stroke can begin. At the precise moment the piston reaches the top of its travel, a sophisticated device called a fuel injector sprays a fine, atomized mist of diesel fuel directly into the chamber of superheated air. The intense heat of the compressed air instantly ignites the diesel fuel, causing a powerful and sustained explosion. This combustion forces the piston down with immense force, generating the high levels of torque for which diesel engines are known. Unlike the quick bang in a petrol engine, the burn in a diesel is slightly more prolonged, creating a strong, continuous push. The final step is the exhaust stroke, which functions in much the same way as in a petrol engine. The piston moves back up the cylinder, pushing the spent gases out through the open exhaust valve. One additional component often found in diesel engines, especially for starting in cold weather, is the glow plug. Because the engine relies on heat from compression, it can struggle to start when the engine block is very cold. A glow plug is a small heating element in the cylinder that preheats the air, helping to ensure that it reaches the necessary temperature for ignition when the engine is first turned over. Both petrol and diesel engines are built around a core set of shared components that work together to convert fuel into motion. The piston is a cylindrical part that moves up and down inside the cylinder. It is connected via a connecting rod to the crankshaft, a complex shaft that converts the piston's linear up and down motion into the rotational motion needed to turn the wheels. The cylinder head sits atop the engine block, sealing the cylinders and housing crucial parts like the valves, which open and close to let air in and exhaust out, and either the spark plugs or fuel injectors. However, the different ignition methods require some unique, specialized parts. Petrol engines require spark plugs to create the spark that ignites the fuel-air mixture. They also use a throttle body to control the amount of air entering the engine, which in turn dictates the engine speed. Older petrol cars used a carburetor to mix the fuel and air, but this has been replaced by more efficient fuel injection systems in modern vehicles. These parts are all dedicated to managing the precise mixture and ignition timing required for the engine to run smoothly and efficiently across a range of speeds. Diesel engines, on the other hand, have their own set of exclusive components. The most critical is the high-pressure fuel injector, a highly engineered device capable of spraying fuel into the cylinder against immense compression. Because they do not use a spark for ignition, they have no need for spark plugs. Instead, they often feature glow plugs to assist with cold starts by preheating the combustion chamber. Furthermore, modern diesel vehicles are equipped with a diesel particulate filter, or DPF, in their exhaust system, which is designed to capture and burn off soot to reduce harmful emissions. In summary, the ultimate showdown between diesel and petrol comes down to a few key distinctions. Petrol engines use spark plugs for ignition, excel in delivering smooth power at high revolutions, and are generally lighter and quieter. Diesel engines use compression for ignition, which makes them more fuel efficient and produces significantly more torque, or pulling power, at lower engine speeds. This makes them ideal for heavy loads and long-distance motorway driving. The choice, therefore, is not about which is better overall, but which is better suited to the specific demands of the driver.